Hi guys, today we're going to look at trig derivatives, not trig derivatives, what am I saying? I need to correct that, that's trig limits. So let's fix that. Derivatives are coming, but not just yet. So let's change this to limits. Alright, very good. Okay, so we're going to talk about trig limits today. And I put the three basic trig functions up here because that's what I want to start with. Now, the idea here is just for us to follow the rules of limits when we're doing these problems. Alright, so the rules for limits are plug in to see if you get an indeterminate form. Well, let's take a look. If we plug 0 into sine of x, everybody knows that sine of 0 is, of course, 0. So there's no other work. It's not 0 over 0, it's not 1 over 1, whatever. So we just say it's 0. The same thing for cosine. The limit as x goes to 0 of cosine, well, you plug 0 in and you get 1, and that's the answer. See? Pretty straightforward already. For tangent, we did the same thing. Plug 0 in. The tan of 0 is 0. So you have the idea of these relationships, and the other trig functions work very similarly. All right, and you just plug in and see what you get. Now the difficulty comes in when we start messing around with it with something like this, the limit as x goes to 0 of sine x over x. Okay, so this is a sneaky guy, and if I plug in right now, okay, if I plug 0 in, I get 0 over 0. So this is indeterminate, which means we have to figure out a different way to get to the answer. Obviously, there's no algebraic solution necessarily that we can go through here. There's no simplification, there's no radicals, there's nothing you can really do to break this down to get it out of the indeterminate form. So what do we do? Well, let's take a look. What I'm going to do is we're going to take a look at this on the calculator. Okay, and I'm going to graph it. See, here we have sine x over x. So what I'm going to do is I'm going to just do a zoom 4 so we can tighten in and look at it. And here's the graph of sine x over x. Now if you take a look at it here, right here it looks like it's approaching 1. So let me just be sure of this. I'm going to turn off the axes for a moment so that you can kind of see what's happening at that point. Okay, so let's look at it again. Here it comes, here it comes. Aha, take a look at right here and you'll see a gap in the graph. Well, that gap in the graph tells me that yes, if we were to plug and evaluate the function there, of course, we'd have that open circle. All right, looks something like this, open circle and back down. Now the cool thing here, the y value of this open circle is 1. Wait a minute, both sides of the limit achieve the same value? Aha, so that allows me to draw the conclusion that the limit as x goes to 0 of sine x over x is equal to 1. Well, that's a good conclusion, but let's verify that on our calculator again, numerically this time. Okay, so what I'm going to do is we're going to set up our table, our window, and do my table start at 0, and delta table we're going to make really small, 0.001. Okay, and then I'm going to look at our table now. Now if you look there, we get our error at 0, but I want you to take a look at 0.001, so immediately to the left of 0, we get a value of 1, and then immediately to the right of 0, we get a 1. Therefore, we're still able to draw this conclusion that sine x over x is 1. Okay, and that's something we need to know, and something we need to share and learn and just bring into our brains. Okay, now on the same note, let's take a look then at the limit as x goes to 0 of tan x over x. Okay, now this also is 0 over 0. Okay, also 0 over 0, so well, we have to do some work with it. Now you do have a couple of options. If we looked at it graphically, we'd know the answer. If we looked at it numerically, we'd know the answer. But I want to break this up in terms of sine and cosine just to really look at it closely. All right, we're going to do it the limit as x goes to 0 of sine, because tangent is sine over cosine, times x cosine x. And we're allowed to write it this way. That cosine just drops at the bottom. Well, let's take a look at what's going on. Okay, I can actually rewrite this as, so let's rewrite it as the limit as x goes to 0 of sine x over x times 1 over cosine x. Okay, well, we know just from what we've just stated here, from right up here, that this is equal to 1. And from our previous thing, we know that cosine of 0, if we substitute in, well, that's going to equal 1. So the overall value is 1. So we can draw the conclusion then that the limit as x goes to 0 of tan x over x equals 1. All right, that's pretty straightforward. Now, in the second part of this video, what I'm going to do is I am going to show you some examples of simplifications, so in case it's just not these two things. All right, so that will be in part 2 coming up in a moment.